If you study physics, chances are you've come across one of these mathematical objects. This is what we call the generalized hypergeometric function. The generalized hypergeometric function, or GHF for short, is, by definition, an infinite series with Pochhammer symbol coefficients and integer powers of z. The GHF is a key subject of interest in mathematical physics, with extensive utility in solutions to differential and integral equations. In quantum mechanics, some GHFs can be found in angular momentum recoupling problems, angular momentum rotation groups, and for representing the Chebyshev-Jordan coefficients. It is to be emphasized that the set examples in quantum mechanics are often evaluated at a unit argument or at z equals 1. However, because it's an infinite series by nature, it is sometimes desirable to find closed form expressions, like this one. Luckily, with the development of finite part integration as a method to solve really hard non-elementary integrals, we can solve this integral and, up to some extent, generalize our solutions to cover multiple cases of the GHF. In this study, we were able to find a general case of this integral with this function, where we can now express the integral as a combination of two f2 As a consequence, this allows us to predict when we can have a closed form expression for a certain GHF based on the value of the argument z. In this case, z should be equal to negative b over c. Here's an example. Without the knowledge of the theorem, we would evaluate this GHF using its infinite series definition. But now, we were able to find a closed form expression when z equals 1. Now, in general, finite part integration can be used to find many more transformation equations for many more different types of functions aside from the one explored in this study. And admittedly, this study is more on the math side, so we can probably try to find applications in physics. That is all. Bye!